Hey, here to learn something new? Well, to keep those knowledge gears greased, remember to subscribe and hit the notification button to get notified when a poppin' fresh video is ready for your consumption. In the history of nerd debates, you have classics like Windows versus Mac, Edison versus Tesla, AMD versus Intel, and now Arduino versus Raspberry Pi. Which one is superior? Which one should you get? Let's find out. Why is it that these two frenemies are always being compared to one another? Probably because they're about the same size, you can control electronic components with them, and they're both very popular amongst the tinkering community. But they couldn't be more different. It's like comparing a calculator to a laptop. Here's why. Let's look at the Arduino. This is the device you want if all you want to do is control electronic components and nothing else. You can add motors, lights, sensors, and even wireless and Bluetooth modules to it, making it the perfect platform for building robots. The heart of the Arduino is this little chip right here. This is known as a microcontroller. Microcontrollers are chips that were created by Texas Instruments, the same people that made it big on developing calculators. So comparing this to a calculator really isn't that far off. These microcontrollers have basically everything they need to store, run, and execute programs right within the chip itself, and they don't require much power to run. You'll often see them powered by 9-volt batteries. Arduinos come in all different shapes and sizes, so no matter what size project you have, there's most likely an Arduino out there for it. They also have options for easily attaching pre-made peripherals called shields. These sit on top of the Arduino like so, and you can use them to easily add Bluetooth, cellular, Ethernet, motor controls, LCDs, and tons of other components. Even though microcontrollers are mostly self-contained, you still have to connect it to a computer in order to program it. But once you've uploaded your code to the microcontroller, you could then disconnect it from the computer and let it run as a standalone device. The code it uses is similar to the C# programming language, but there are a few third-party options out there for programming it using Python or Blockly. But this Arduino software that it's running is the primary way to program the microcontroller. Alright, Raspberry Pi, come on down, it's your time in the hot seat. Okay, unlike the Arduino and its do-it-all microcontroller, the Raspberry Pi sports a microprocessor, which requires assistance from separate chips to be able to store, run, and execute code. So if you're familiar with the motherboard of a computer, the microprocessor is the processor, the heart of the computer. And then you have the RAM, your graphics controller, Ethernet controller, and your hard drive, and all these other separate components that are required for the computer to run. So if you shrink all that down to a single board, you've got yourself a Raspberry Pi. So being an entire computer itself, you can see why it's difficult to compare it to an Arduino. The Pi has built-in USB, graphics, wireless, Bluetooth, and audio, and it runs the Linux operating system, so you can literally use it like you use any other computer. But because of that, it also requires more power than the Arduino to run, and the added layers of chips and software not only make it a lot more complex than the Arduino, but also make it more complex to operate. So why then does it get compared so much to the Arduino? It's because of these. These are known as general purpose input-output pins, and like the Arduino, they can be used to control other electronic components. While they aren't as extensive as the pins on the Arduino, they can still be used to do a lot of the same things, like controlling lights, motors, sensors, and LCDs. To program these GPIO pins, instead of connecting it to a separate computer like you would have to do with an Arduino, you can program them directly from the Pi since it is itself a computer. Python is the primary programming language for programming these pins, but then you can also use some of the more popular programming languages that are out there. Similar to the Arduino shields, the Pis have something called hats that sit on top of the GPIO pins and allow you to easily add pre-made components. Pis have 3 different sizes to choose from as well, so that you can get the right one that fits your project size. Enough with the details already, just tell me which one I should buy. Well, since they're completely different tools, it depends on what type of project you're doing. You wouldn't want to buy an entire computer just to solve a math problem, and you wouldn't want to buy a calculator to watch YouTube videos. If all you want to do is work with sensors and robotics, then buying a Raspberry Pi would be overkill. An Arduino would be a better choice for that. However, if you wanted to add elements of a computer to your robotics or sensory projects, like adding a webcam, USB storage, or making it a web server, then a Raspberry Pi might be better. Look at it this way. If you wanted to build a Bluetooth controlled toy car, use an Arduino. If you wanted to build a Bluetooth controlled toy car with a webcam that live streams to Twitch, get a Raspberry Pi. Here's my recommendation. If you're a beginner just getting started tinkering, I recommend going with Arduino. It's designed for beginners and it's simple to use. Once you're comfortable with that, you can move on to the Raspberry Pi and add that level of operating system and software difficulty. That's it for this chapter of the Field Guide. That's one more tinkering tool to add to your toolbox. Want to suggest a guide? Head on over to tinkernut.com/ideas to submit your idea. If you want more tinkering videos, you can click here, or please be kind enough to like, subscribe, or comment. If you made it this far, here's your reward. The very first domain name ever registered was www.symbolics.com, and it was registered on March 15th, 1985.